These days we're sending around a lot of private information through the web, and your passwords and credit card numbers and emails are all protected by something called encryption. Encryption is a way of taking information and modifying it so that it's hard or even impossible for unauthorized viewers to understand it. A cipher is an algorithm or technique used to encrypt information. While modern ciphers can be very complex and very difficult to break, today we'll be looking at one of a much older method. You may have heard of it. It's called the Caesar cipher. The Caesar cipher was named after Julius Caesar, a famous Roman dictator who would use the Caesar cipher and basically shift letters forward in the alphabet whenever he wanted to send secret messages to his generals. To look at some of the details of the Caesar cipher, we'll be handing it over to Mari.
A Caesar cipher is an encryption technique that takes in a normal string, called a plain text, and substitutes each letter in that string with another letter that's a fixed number of spaces down in the alphabet. Confused? Let me see if I can clarify things with an example. Let's encode, also known as in cipher, a plain text into a ciphertext, where all of the letters are shifted 3 letters down the alphabet. This number 3 is called the key. If we write out all possible letters and letters you replace it with under our key, you'd see something like this.
Now, on to the actual enciphering. Say that our plain text is the word lazy. The first character in the plain text, L, would become O, since O is 3 letters after L. The second character, A, would become D. Now, the third letter, Z. What's 3 letters below Z? It turns out that if you reach the end of the alphabet when shifting down, you're supposed to wrap around. This means that Z would become C, since we wrap around from Z to A to move 1 character, 1 letter down, and A to C to move 2 letters down. And finally, the fourth letter, Y, will become B. Now that you know how to encipher a plain text using a Caesar cipher, you're ready to hear about the Caesar cipher program that you're supposed to be writing. Here, we pulled up our solution so we can show you how it all should come together. In the first part, we'll write the encipher function. The input to this function is a plain text string and the integer key, and it returns the corresponding ciphertext. Let's try to encipher the string lazy with the key of 3 like we did before. So let's just type that in. Nice. Here we have the letters O, D, C, B, which is exactly the letters that we got when we did it by hand. Then, in the second part, we'll be writing the decipher function. Here, we're given a string enciphered using a Caesar cipher, but we're not sure what the key is that we're supposed to use. Your goal is to guess the key and return the deciphered string that corresponds to that guess. In the best case scenario, that deciphered string will be equivalent to the plain text. Let's try to decipher this really interesting string right here. Nice. It actually returned an intelligible plain text, which is what we expect.
So, here we are in the Python shell, and we're going to go over the strategy for creating encrypt using the Caesar cipher, as well as go over some useful functions built into Python that you might want to use. We recommend writing a helper function that shifts a single letter by a given value. So, one thing that might be useful is being able to convert your letter to its corresponding ASCII valued number. For example, ord of lowercase a gives you 97, whereas ord of lowercase z gives you 122. The uppercase letters have different ASCII values than the lowercase letters, as you can see. And if your number is between 65 and 90, it'll be uppercase. If it's between 97 and 122, it'll be lowercase. And if it's outside of either of those ranges, it won't be an alphabetic character, and your Caesar cipher shouldn't do anything to it. Your essential strategy for converting a single letter should be to convert it to its number, then add your key to it, Then use the modulo operator to bring it back into range of being lowercase or uppercase if it was to begin with. And then to convert from your number back to your new character using the CHR, or character method. So that will take 97 and convert it back to an A, for example. Then, once you have your function that takes a single letter and shifts it by your key, you can use a list comprehension to make a list of all your newly enciphered letters. And then you can take your list and join it all together using Python's join function. That should outline a pretty basic strategy for how you'll make Encipher. So, if we're given a ciphertext and we also know the key, we can take 26 minus the key and decipher it just like we'd encipher it. However, if we don't know the key, things start to get a little bit more complicated. We can use a list comprehension to make a list of all the possible candidate strings, and we know a way for our code to make an educated guess as to which one is our desired message. Let's assume the desired message is going to be in English. Let's use some of the information we know about English to take an educated guess, or create a heuristic that lets us figure out which one is our desired message. For example, we know that English has a lot of vowels, so maybe the candidate string with the most vowels might be the right one. However, maybe we want to consider all of the letters. You may have already written a function that takes the Scrabble score of a string. And we know that in Scrabble, more common letters are given fewer points. So perhaps the string with the smallest Scrabble score is likely to be English. If you'd like to be more precise, we've given you a function that takes in a letter and gives you a frequency, or how common it shows up in typical English. You might find that taking the sum of the letter frequencies across the strings gives you a good estimate of how likely that string is to be English. And then you take the one with the best frequency score. Some more advanced ways that you don't quite expect involve maybe using dictionaries, or finding which combinations of letters are more common. However, we think that the single letter approach should work pretty well, but you're definitely encouraged to experiment and try your own ways.
Once you have a way of scoring a string for its Englishness, we're now ready to put everything together and write the decipher function. The first thing we'll need to do is create a list comprehension that generates a list of all possible candidate strings. The next thing we'll need to do is use that list in a list comprehension to create a new list. This new list will have an element for each candidate string, and that element will be a list consisting of two items. The first item is a score, and the second item is the candidate string that led to us having that score. And then finally, we can use this new list to find the highest score, and then return the candidate string that led us to having that higher score. And that pretty much wraps up how to write the decipher function. Good luck.